All right. The other day, we did the trig part of this. Yesterday, I returned your similar and congruent triangles assignments, which were very well done overall, but there's a couple little things that got missed, and you may want to see this for me to touch base on that stuff, or you're going to want to look that over. I also have your tests marked. I got right to it yesterday, so you'll have those back as well, and solutions will get posted. So that's all going to happen. Yeah, please. I'll try to drag my feet slowly so you miss as little as possible, okay? What's that? No, and there's a reason for that, and it's nothing, it's not your fault or anything like that, but you'll get it back as soon as I finish this, yes? I promise. I worked hard to have it ready for you. So this is the review of Unit 7, similar and congruent triangles. In similar triangles, corresponding angles are equal, and the ratio of the corresponding sides are equal. A couple people on the assignment missed one of those two things. I said, how do you know if triangles are similar? And they say, oh, if the angles are equal. Yes, so true. I was so happy to see it. Giant check mark. Or the ratios of the corresponding sides are equal. And what's good news about this is, if you can prove one, you can use the other. That is, if you can prove the angles are all equal, you can use the fact that the corresponding sides are equal. Or if you can prove the corresponding sides are equal, the corresponding sides are, oh, we did a great job using the words, the ratios. What's the other word that you can use there? Proportionate. If they're proportionate, and some of you used regular language instead and said, oh, if they're all the same multiple or something like that. Yeah, I loved all of that. But you had to have both facts there. So, many of the questions, we use the angles to prove that two triangles are similar. And technically, we found out as the chapter went on that you only have to prove two angles. And many of you on your proofs only prove two angles, because you by then knew. You're like, once two angles are equal, the third angle has to be equal. Some of you went ahead and proved the third angle as well, and I like that too. But technically, the theorem is only angle, angle. How are we going to get there? Most questions using either the F pattern, the X pattern, or the Z pattern. Some of you labeled these wrong. You used corresponding, but called it opposite. Or you used opposite, but called it given, or something like that. So don't be too upset about that. You might consider that nitpicky when I took marks off when you used the wrong word there, but I was trying to draw your attention to the words. Oh. Well, that's good, because I have one left over. So, oh, no, I don't. All I've got is my original. Oh, no, I'm lying. There it is. You almost got the one that has colors on it. That's good. All right. Prove the two triangles are similar. Let's try and get the words right. So you got the words right here if you need it tomorrow. Which two angles are equal? What's that? A and D. So true. I'm going to use the fancy naming just in case, because when the triangles overlap, you need the fancy naming. Here you don't. You could just use angle A, because angle A is only that angle. There's no confusion about that. But I'm going to use the fancy naming. Angle BAC equals angle BAC EDC. Now notice, friends, what you said is still true. He said angle A equals angle D. Look at BAC, EDC. The A and the D are still in the middle. Yeah. What word? That's given. That's when it's given. And I'm glad this CCA prep mentions that, because that was a little problem on the test, or sorry, on the assignment, is that you're using the wrong words. That's given. They told us that's true. We can look right at that and see that's true. All right. Now we need another angle. If we're going to prove these are similar, we need one more angle.
Angle DCE.
Okay, let me get that down. Angle DCE equals angle ACB. Yes? Oh, opposite. Yeah, let me put little arcs on there so you can see what we're talking about. There and there. Opposite. That's the opposite situation. Some of you called the Z pattern, you called those opposite. You're like, oh, they're opposite to each other. Yeah, I guess I know what you're saying. But technically, the ones that are opposite are right here in an X pattern right there. Okay? Now, therefore, I'm done. Therefore, triangle BAC is similar to triangle EDC by angle similarity. Once I had two angles the same, the third angle was the same. That's the end of that part of the question. Many of the assignment questions had two parts to them. Prove they're similar, yes? Then now solve for x's and y's. Let me say that again. Many questions have two parts to them. Prove they're similar using your angle theorems, then solve for some sides now that you know that's true. Now I saw a hand and all that, and I kept moving to finish off my explanation. Where was that? Did somebody have their hand up? Did I answer your question as I kept going? Is that what happened? Oh, that's what happened. Okay. Well, I apologize for that. I didn't mean to do that. I just didn't want to get my brain sidetracked and forget what I was saying. Austin, question.
What's similar?
Right here. Angle similarity. And angle similarity says once you've got two angles the same, that third angle is going to be the same.
Okay.
Because they have to add up to 180. And now I know the triangles are similar. Because the big fact at the start here, in similar triangles, corresponding angles are equal. All the angles are equal. And back to what a similar triangle is, if I draw a triangle on a page, a small one, and then I go to the photocopier, and I go, oh, blow this up so the kids can use it as an investigation, it's still the same triangle, sort of. It's not the same side lengths, but it's got all the same angles. It's similar. It's just been blown up by, if it's been all the sides have been multiplied by 2, they're all been multiplied by 2. Maybe they're all multiplied by 3, or 5.5, or I don't know what. Depends on what setting I use on the photocopier. Any questions about that? I hope that in combination with getting your assignment back, you go, okay, I get now exactly how this needs to look tomorrow. By the way, look, CCA out of 35 marks. It's not meant to be a scramble thing. It's meant like, hey, do you know what you're doing here? Yeah, okay, I'm not saying that all the questions are easy. That's not what I'm saying. It's not meant to just overwhelm me. It's not like an exam where it's like, oh, look at all this stuff I got to know. Explain why triangle EFG is similar to RST. So I need to prove the angles are all the same. I can't do that. I don't have enough angles. We have 90. That's only one angle. I could say the two angles are equal. Sides, yes? In similar triangles. I know you got SOHCAHTOA in your back pocket. I'm aware of that. And if someone went through all the process of doing SOHCAHTOA and proved these were similar triangles, I would accept that. But that's not really what the similar triangle chapter was asking for. It says, okay, either all the angles are the same or the ratios of all the sides are equal. Somebody took that first triangle and blew it up to make the second triangle, so all the ratios should be the same. So let's compare the ratios. I go big to small or small to big, so I don't get confused about what sides I'm talking about. I start with the big side of the big triangle. So I go, okay, that's RT. Rob Todd, ha, it's my side. RT over EG, 7.5 over 5 equals, you punch it in your calculator. Because sometimes the ratio is not something nice. Some of you were doing these questions by just looking, oh, it's double, it's triple. That works sometimes. But sometimes the ratio is a little bit nastier. This one's not too bad. 1.5. So if this is truly going to be similar, I better find that the ratios are all 1.5. Next, I go the next biggest one. That's how I match them up. The next biggest one in this triangle is the ST. ST over the middle one in here, which is GF. That's going to be 6 over 4. Punch that in my calculator. Okay, come on. Be the same thing. 6 divided by 4, 1.5. You're like, ha, it's going to work. They're going to be similar. Now do the small ones. Yes, inside you do. Yes? Is there a side similarity theorem? Yes, there actually is. But no, we're not going to make that jump. SR over, what's the small one over here? EF. 4.5 over 3. Come on. 4.5 divided by 3. Well, I think it's 1.5, yes. And then I'll do the fancy sentence. Since the sides are all proportionate. Triangle EFG, similar triangle RST. I totally accept it when people said, since all the sides are multiples, are the same multiple. You can use regular language. You don't have to use the word proportionate, but many of you did use the word proportionate. We're getting used to that. Proportionate just means all of the proportions were the same. Do you remember the word proportion from elementary school? The ratios are sometimes called proportions. Yeah? Sorry, two pairs of ratios are called proportions. Yes. How's that? You okay? You like? Yeah. All right. Let's manage our energy here, see what we got left. I got to do a long one, another long one, and then we're done. Okay. Although the numbering goes off here, does it? Example 1, 2, 3, 5. We're not there yet, but that's actually going to be example 4, isn't it? All right. All right. Here's where some people fell off the train and lost a mark or two on the assignment. Yeah? Prove similarity. All right? So when you get to a question like this tomorrow, draw a line down your page and go, okay, I got to do two things. I got to do what I've already been doing, which is prove similarity. I got to prove that these are similar. Then, after that, I can get to work and use my proportions, which the proportions went really well. I was really happy with how well people did proportions. Okay? So, prove they're similar. What do I need? You know, the angle's the same. Oh, even just two angles. 105, 105, 30. Oh, hey, yeah, okay. Pretty nice here, right? Yeah? So, angle ABC equals, okay, careful now. Technically, I've got to get this the right way around. A was the angle that's not 30, so that's x. Z was the angle that was 30. Yes, okay. It's a little tiny bit careful there. Why are those equal?
Given.
Given. That's what given means. Look, it's right there on the page. Given. Then, angle, I'm going after that other one, ACB. Careful now. Just slow down for just a second to make sure you get this right. A was the angle that wasn't 30. So that's my x. And now I want to go to z. Y. C is z. Oh, look at the middle letter. See, the middle letter sort of helps you there. The middle letter, C is z. Good. What's that? Is that? Why is that? Also given. Therefore, triangle ABC, similar triangle XYZ, due to angle similarity. We only need two. Well, that's not true. It's not true. You need three. But once you have two, you know the third one will be the same. Has to be. They add to 180. Okay? That part was missed by some people or wasn't complete by some people. Okay? Not bad. I was pretty happy. I marked that at a very few marks because I went, yeah, I know. Once you see the unknowns, you're like, oh, I'm going to go do the unknowns. Set up the corresponding side length ratios. Find the helpful ratio. Okay, so what I want then, they want me to solve for yz, which is x. So yz over, what's the corresponding side in the other triangle? BC. BC is right. Here's how I do it. I look at yz and I go, that's the side that goes from 105 to 30. So I go over here, what's the side that goes from 105 to 30? That's BC. Now I need a ratio of stuff I know. AC and XZ, only I put YZ in the top here, so I got to put XZ on the top here. X to Z was nothing to 30. So that's AC. Oh, that's what she said. AC, she had it the right way around. Yeah, she thought it out. She went, okay, just use the angles to know which way you got to go there. Then fill in what you want here. X over 6 equals 10 over 8. I just filled in the sides right from the triangles. XZ was 10, AC was 8, X was YZ, and BC was 6. Now what? Cross multiply. Some of you are skipping through. If the unknown's in the top, you're like, I don't have to go through cross multiply. Some of you are like, hey, let's take the thinking out of it. I'll just, every time this comes up, I'll just cross multiply. That works so nicely. 8x equals 60. That means x is 60 over 8. Reduce that fraction, 15 over 2. X equals 7.5. Therefore, YZ equals 7.5. This particular question didn't have meters, centimeters, or feet on it, but there was a couple of people on the test where the question was in meters and they wrote feet, or it said centimeters and they wrote meters. That worries me just a little bit. When you forget to put the unit on there, okay, I go like, oh, okay, forgot to put the unit on there. I tried to be generous and see if you wrote it somewhere else. But when you write a completely different unit that was in the question, that's a problem. I know it's a problem because NASA lost a Planet rover doing this once. True story. They used feet instead of meters in the calculations, and the brakes to the rocket didn't turn on until after it had smashed into the ground. It took them a while to figure it out. Yeah, just bad calculations. So you're like, oh, well, what's the big deal? You took a mark off for units. Why are you doing that? So you don't kill a rover someday. Thank goodness it wasn't a regular, somebody on it. Whoops. Sorry, family. It's supposed to be a 7. See, what happened was, it was just feet, meters, Miss Todd. Don't be so. Yikes. What's that? It happened to me? I haven't been to space. I love some of my favorite courses in university were astrophysics, understanding what's going on out there. Yeah, good stuff.
Why didn't they just record it and send it back with the
Neil deGrasse Tyson, the guy. Oh, he is the guy. Yeah, he is the guy. Yeah. Don't watch too much of it. He says stuff that's so wise you might not want to know. You watch an interview with him and he says something, you're like, oh, just rocks your whole foundation. Yeah. Last one.
That's what I did. Made my computer class.
A 5-meter ladder rests against the wall. Another ladder, 12 meters long, is also resting against the wall, but parallel to the first ladder. What? Hold on. People get upset about this, and a couple people on the test I helped out just a little bit. They said, well, what's going on? I'm like, where's the ground? I'm like, okay, well, the ground is down here. Ground. Okay, I can do that. And that's all the help I gave them, it seemed. Like, oh, okay, I'm okay now. I'm like, just start drawing something. Then a wall. It mentions vertical wall, but come on. If they say wall, we'll assume vertical, unless they say otherwise. Most walls are vertical, yes? Yes. Vertical means at 90. Yes. Okay, good. Ladder 1, and then ladder 2 is parallel to the first ladder. I don't know why you would do this. Let's see how I do. Does it look parallel?
Maybe it's in stubble, ladder climbing like you're.
Yeah, maybe they're in storage. Yeah, good.
store a 12-meter ladder.
I don't have good reasons why this happened. Draw a diagram. Is the diagram complete? No, I can do a little better. A 5-meter ladder. It's good? A 5-meter ladder rests against a vertical wall with its base 3 meters from the wall. Here's a little trick when you're drawing these things to indicate exactly how much horizontal you mean. Because if you just write a 3 down here, everybody's going to be confused about what you mean. See this little E? E. That's one way to handle it. Some people draw lines at either end and arrows to indicate. That's good too. I'll do that for the second one, okay? 3 meters small. Another ladder, 12 meters long, is resting against the wall parallel to the first one. Draw a diagram. Okay, diagram done. Prove similarity exists. All right, to do this correctly, I better put some letters on here. A, B, C, D, E. Now, first of all, I don't mean to, I hope you don't take this insulting. But this is important. I hope you're like, yes. Yeah? And you take it the way I mean it. Can you see 2 triangles? Yeah. Okay, all right. That's a visualization thing. Yeah, big triangle, little triangle. Prove similarity. Give me an angle that's the same in both triangles. ACB, oh, she's gone after the easy one. ACB, DCE, given. And it's a whole sentence saying the wall's vertical all the time. It's vertical in the first triangle. It's vertical in the second triangle. Okay? Now, the second one, not quite so easy. Austin's got it. He says, tell me.
Angle ABC and angle DEC because F pattern.
Okay, good. Let me write them down first, okay? Angle ABC equals angle DEC. Yes? But I'm just going to add something, okay? For anyone who doesn't see these as easily or doesn't name them as easily, I encourage you to put the arcs on there and go, oh, wait, I know these are equal. And putting the arc on there will help you manage the naming of the whole thing. But he says F pattern, which I will accept as an answer, but does anyone have corresponding? Yes. I must tell you, grade 10 teachers love the word corresponding. Yes? In the future, most of us just say F pattern. Okay? I'm not trying to upset anybody. I'm just trying to tell you, F pattern will be fine moving forward. Yes?
Well, maybe using full word correspondence.
In grade 10, maybe. But not with this guy as your grade 10 teacher, because you can see I'm sort of going, we'll just use the word F pattern. Yes? Okay. Oh, okay. Therefore, triangle ABC, similar triangle DEC, due to angle similarity. A lot of similar triangle questions play out like that. Prove they're similar by angle similarity, and then apparently solve for something in the question using proportional type thinking. It says, how far up does the ladder reach?
12 meters.
What side are we actually after?
Minor.
BC. Let me highlight it. How far up the wall? BC. I say I can't get BC first. What can I get first? Destiny, I can't tell if your hand's up. Is it? What's that? She says EC is what she's going to go after first. And I totally agree with her. We can do EC. Maybe you didn't want to go after EC. How is she going to get EC? Pythagorean theorem. Yes? EC squared equals 5 squared minus 3 squared. I thought Pythagorean theorem was add. Hold on. Yes, I'm with you. Ask your question in just a second. Or if you weren't going to ask that question, do me a favor for the sake of the video. Ask that question in just a second. I thought Pythagorean theorem was add. I'm like, okay, just a second. EC squared equals 16. EC equals root 16. EC equals 4, and put it, oh, you guys were so good at this. Put it on the picture. Right there. 4. I'm running out of space here. Who's going to ask my question that I loaded in the gun for you?
That's not the question.
No, that was. I will answer that question. Why is it subtract? I thought Pythagorean theorem was add. Why does it subtract? Hypotenuse is add. Other sides are subtract because they got to be smaller. All right. Yes. Yes, supposed to know that. Uh-oh. Oh, it worked, but with a delay. Yes.
Just so you don't accidentally kill someone one day, can you put the unit on them?
Oh, yeah. Meters. Good. Thank you.
Yep, because of NASA spacecraft.
We found EC was 4. Can we get BC now? Yes. BC over EC equals what? AB over DE. Do I have enough space here? I don't know. Let's see. It's going to be close. I'm going to go sideways. No, I'll go right down here. BC 12 over 4. BC over, no, not 12. What am I doing? BC over 4 equals 12 over 5. Yeah, it's not a nice multiple this time, is it? 5 BC equals 48. BC is 48 over 5. BC equals 9.6 meters. Therefore, the ladder reaches 9.6 meters up the wall. How far up the wall does each ladder reach? Oh! The big ladder. Little ladder. 4 meters up the wall. Okay? I found that in the process, didn't I? I didn't have to go back and do any extra work there because I already figured that out by the nature of the way I solved the question. Incidentally, if you thought about going for AC first, that could have worked too. AC, then Pythagorean theorem on the big triangle. So either way, you had to use proportional sides and Pythagorean theorem, but you can do it in another order if you wanted to. Do you have any questions?